Hi, I'm Hannah Bonvecchio, and this is my Lab 1 on constant velocity. The object of this lab is to see how you can predict the final position when the velocity is constant. We also will compare our predicted position to the observed position just to see how accurate that prediction is. Ideally, they are equal. These are the basic equations, and you need to know Newton's first and second laws for this lab. Most importantly, we need to know that distance equals vi plus vf divided by 2 times delta t. We can assume that acceleration is constant because of the constant velocity, so in the formal kinematic equation, acceleration is 0. Vi plus vf divided by 2 is the average velocity of the observed position, and we can use that to calculate our predicted position. So first, we conduct the experiment. We use whiteboard cleaner, but you could use literally any rollable object. You also need a calibration stick to set the position and tracker. These are also some important tips just to keep in mind when doing the experiment. So if you're using ramp, hold it steady, make sure that your camera is steady for tracker, stuff like that. So next, we analyze the object and tracker and identify our system and our surroundings. Here, the whiteboard cleaner is the system, and then ramp, floor, and the ruler are all the surroundings because of the constant velocity. So friction is assumed to be negative, so the floor doesn't have an effect. You also don't need the y component in tracker because the object is only moving in the x direction. This gives us our observed positions. Now we can go into Python and edit the base code. We use the initial position and velocity from the observed, where velocity is the average velocity. Then we set the initial and final time and then add in the kinematic equation. When velocity is constant, d equals r sub I plus v average times delta t. When the observed and predicted positions are compared, the positions are only different by like 0.4 meters. This shows that the object was not actually moving at a constant velocity, meaning that it slowed or accelerated. So here are just a couple possible sources of error for this experiment. One, it's not a constant velocity, so friction from the floor either slows the object or there's acceleration from the ramp. The object also probably changed direction because of it was rolling on an uneven surface. And there also may be some error from tracker, just for calculating the observed positions. So what happens if the x-axis was flipped from x to negative x? This actually doesn't affect the magnitude because it's always positive, so you're squaring and taking the square root. However, the signs of the initial velocity and distance would be opposite. So is it possible to calculate all of the forces that contribute to the net force? If this object were moving at a constant velocity, force, weight, and the normal force are equal, and friction is 0. This would make the net force constant. However, there is a friction force that we didn't really account for in the equation, so we can't really identify what balances out the net force without knowing friction. And then here is an example of what that free body diagram would kind of look like.